In this question, we are asked to convert from grams to volume in either milliliters or centimeters cubed using the density. In an earlier video attached to this playlist on YouTube, you can see where I talk about how a centimeter cubed and a milliliter are the same thing. So here we want to use density as a conversion factor. Like many problems in ALEKS, this is certainly not the only way you can do this, but this does come up in the chemistry lab quite often, and this is a good way to do it because often we're not just converting from milliliters or grams to milliliters from one unit to another using the density. We're often using it to do subsequent calculations. So doing it by dimensional analysis can be quite useful. So in order to do this by dimensional analysis, we need an equality. And the equality that for density is 1.26, in this case, grams equals 1 milliliter or 1 centimeter cubed. And again, milliliters and centimeters cubed are the same thing. So here, this says that this glycerol has a density of 1.26 grams per centimeter cubed or grams per milliliter. Said another way, if you have 1.26 grams of glycerol, it will have a volume of 1 milliliter. Or if you have 1 milliliter of glycerol, it will have a mass of 1.26 grams. So it's the number on the top, grams per 1 milliliter or 1 centimeter cubed. Now that we have an equality, we can do dimensional analysis. Starting with 10.0 grams times, we want to put the 1.26 grams on the bottom, so grams will cancel out, and the 1 milliliter on the top. When you do this math on your calculator, you will get 7.9365 and a bunch of other digits. However, since this is 3 significant figures and this is 3 significant figures, we want to round this to 3 significant figures, which is 7.94 milliliters or centimeters cubed. On the bottom, we want to do the same thing, except we're going the opposite direction. In this case, we're starting with 50 milliliters, and we want to find the mass of, in this case, methyl acetate. So starting with 50.0 milliliters, again, we have the same type of equality, but for methyl acetate, it does have a different density, so it's 0.934 grams equals 1 milliliter, because it's 0.934 grams per milliliter, or grams per centimeter cubed. Times, in this case, we want to put the 1 milliliter on the bottom so that it will cancel out, and the 0.934 grams on the top. When you do this math, you get, by coincidence, the right number of significant figures, which is 46.7 milliliters cancel out, and we're left with grams. So again, this is just one way you can do this. You can, of course, also use the density equals mass divided by volume equation, but I feel like doing it by dimensional analysis is very useful because it helps us practice the dimensional analysis skills, which come up quite often in chemistry.